Hello, this is Ms. DB, and today we are going to do part 2 of 9.4 operations with functions. And today we're going to learn how to write and evaluate composite functions. These are kind of fun. So this is another operation that is just for functions. Adding, subtracting, multiplying, and dividing. We can do that with numbers. We can do it with expressions, but composition of functions only works for functions. So here's what we're going to do. There's two different ways of writing it. They can use this little O. It's not an O, it's not fog, but it means composition. But our book generally will write it with just parentheses. So this is that the composition of f and g of x. The domain of the composition f of g of x is all values of x in the domain of g, such that g of x is in the domain of f. We're not going to get too worried about the domain in Algebra 2, but when you take pre-calculus and college algebra, you'll have to be a little more careful about the domain. Okay, so this is what the composition of functions is. To find the composition f of g of 1, first you would find g of 1. You would do the inside part first. And g of 1, here's g of 1 is equal to 4. And then you use 4 as the input for f. So here's the function f, and it has an input of 4, then it goes to 8. So you go from the inside out. Now it's opposite if it was written as, are these both written the same? Yeah, it would be different if it was g of f of x. Then you would do the f of x part first. So if this was a 1, then you would, oh, there isn't a f of 1. Let's say it was f of 6. You would do the f of 6 part first, and that's 12, and then you'd go over here, and if you'd have to, it doesn't work backwards. But it does matter which order you do these. So the order of function operations is the same as the order of operations for numbers and expressions. So you would organize and find the inside first and then substitute that result into f. So it's read f of g of x. And be very careful to see whether you're doing multiplication of functions, which they'll usually put both of those parts in parentheses, or composition, which is f of g of x. They're different answers. You will not get the same answer if you do both of them. All right, let's look at an example. It'll make a lot more sense when you see some examples. So we have that the function f of x is 2 to the x power, and g of x is 7 minus x. Find each value. F of g of 4. Now remember, we do this part first. We work from the inside out. So first we're going to find g of 4. That's easy enough. You just replace the x with 4. So g of 4 is equal to 7 minus 4, which is 3. Now you know that g of 4 is equal to 3, so now you'd find f of 3. And you'd plug 3 in for x, and you'd have 2 to the third power, and you'll get 2 times 2 times 2 is 8. Now let's watch that step by step. Okay, our first step is to find g of 4. Plug 4 in, and you will get 7 minus 4 is 3. Step 2 is to take that value and plug it in instead of x in f of x. So f of 3 is equal to 2 to the third is equal to 8. That's your answer. You don't go any farther than that. Let's do another one. We want, this time, g of f of 4. This time, this is the part we'll figure out first. So we replace x with 4, and we'd get 2 to the fourth, which is 16, and then we would use that for g of x. So we get 16 there. Then we take the 16 and we put it in, instead of x, in the g of x. So g of x equals 7 minus 16, so you would get 7 minus, or you'd get negative 9 there. And that's the answer. Now if you did it the other way, you'd get a different answer, so you have to make sure you do them in the right order. Here's the first few problems from your worksheet. Number 1 has been started, It's g of h of 10. So I started finding h of 10. So I use this function. I plug 10 in, and 10 squared is 100. 100 minus 9 is 91. Now I'm ready to find g of 91. So now I'm going to go to this part, and I'm going to use the 91 instead of the x. So 91 minus 3 is 88. And that's your answer then. Okay, let's look at number 3. F of g of 2. So I'd first find the g of 2. And g of 2 would be 2 minus 3 is negative 1. Now I use the negative 1 for f instead of x. So I put f of negative 1. So now I go up here. F of x is equal to x. Oh, it's just negative 1. I don't even have to do any work because the x is equal to the x there. Let's look at number 4. G of k of 3. So we have to do k of 3 first. Here's the k function. So that would be 2 times 3. So k of 3 is equal to 6. Then when you know that, you're ready to find g of 6. And g of 6 is, g of x is x minus 3. So I replace x with 6, 6 minus 3, and I'll let you finish it. Easy enough. Okay, let's do it with just algebra. We can find the rule without finding it for a specific value. There's no difference except that they're just a little bit trickier and they won't simplify to answers. Okay, so f of g of x. The first thing you do is the g of x. So the g of x is x over 1 minus x. So instead of x, I'm going to write x over 1 minus x. That's what f of x is going to be. And then f of x is x squared minus 1. So I have to take my new x, which is actually x over 1 minus x, and I have to square it and then subtract 1. So when I square that, I would have, it's a little bit tricky, but I would have well, it's squared, and it looks like they just took it times 2. It would not be this. It would be x squared minus 1 on the top, because you have to square that. And on the bottom, you would have 1 minus x squared. And if you wanted to FOIL that out, you could. You also have to say what the domain cannot be. You cannot let either part of this have the denominator equal to 0. So you can't let x be 1, because if it was, you'd have 1 minus 1 or 0 for the g of x. So x can be any real numbers except x cannot be equal to 1, because then you would have a undefined value. All right, in this one, we have f of x equals x squared minus 1, and g of x equals x over 1 minus x. And so they're the same ones again. Again, x cannot equal 1. And we are going to find, this time, g of f of x. So this time we want g of x squared minus 1. So we're going to be using this, and every time we see an x, we're going to put x squared minus 1. We're replacing each x with x squared minus 1. So when we do that, I'll let them write it because it'll be a little bit neater. We'll get x squared minus 1 over 1 minus x squared minus 1. And then we simplify. So the top really can't be simplified, but the bottom we can simplify, because 1 minus 1, or 1 minus a negative 1, is the same as 2, and then we have our minus x squared. Now we cannot let x be 1 because of the original part, but we also can't let x be plus or minus square root of 2. Here's why. If I took 2 minus x squared equal to 0, I'm going to add x squared to both sides so that my x is positive. And then I would take the square root of both sides to find x. And when I do that, when you take the square root, you get plus or minus. So I have x is equal to plus or minus the square root of 2. That's what x cannot be for this function. It also cannot be Here, let me rewrite this, or erase this so you can see everything. And g of 1 is undefined. Okay, so you have to make sure that you pay attention to that. Let's see. We have f of x equals 3x minus 4, and g of x equals the square root of x plus 2, and we're going to write the composite f of g of x. So g of x is 3x minus 4, and we have to plug that in. Simplify, we have 3 times the square root of x plus 6 minus 4, and then you can also simplify that a little bit and get 3 times the square root of x plus 2. So all we did for this one is we took what g of x, this was our g of x, and we plugged that in every time we saw an x, and then we simplified. The domain needs to be positive numbers because the square root of x needs to be a positive number to make this be true, to make it be valid, defined. Okay, time for some problems from your worksheet. So in the first one, number 11, f of g of x is equal to x squared. So we are going to use that for x in f of x. So we're going to have 1 over 2, and then stop before you write x, and instead of x, you're going to write x squared. Now, if you can simplify, simplify, but this one you really can't. The answer is just going to be 1 over 2x squared. X cannot be equal to 0 because then you would have 0 in the denominator. Let's look at number 13. 13 says h of k of x. Well, k of x is the square root of x. And I'm going to plug that in wherever I see an x in the h of x. So h of k of x is going to equal the square root of x minus 8. That's really all you can do for this one because there's nothing to simplify. It's already simplified. One more example, f of k of x. Let's change pen color here. Here is f of x, here is k of x. Again, we're going to plug in the square root of x right here. So we'll have 1 over 2x, but instead of x, we'll write the square root of x. And then we don't leave the square root in the denominator, so we would multiply top and bottom by the square root of x. And we'd get 1 times the square root of x over 2 times the square root of x times the square root of x. That's just x, so we'd have 2x on the denominator. X cannot equal 0 because then you would have 0 in the denominator. So that's how you do these problems. They're not too bad. Let me know if you have any questions. Thank you very much.